Swayam Prabha. Digital India. Educated India.
Welcome to lecture 15. In today's lecture, we will move forward with our journey from where we left in the previous lectures. So, if you will recollect that we have talked about the double diamond design process. So, the double diamond design process has been discussed in previous lectures, and today we will see how this design process can be used for creating innovative smart products. So, we will look specifically at how to define problems. Okay. So, we have talked a lot about the discovery phase of the double diamond design process, but now we need to move further and look at the next phase, which is the define phase. So, at the end of today's lecture, you would have understood the importance of the problem definition in the design process. You would have understood key methods for use in the define phase, and you would have learnt how to apply these methods to provide problem definitions for the develop phase. So, let us recollect what the design process is all about. So, this is our double diamond. So, I have talked a lot about discovery. So, we have spent a lot of time understanding discovery, and this is very often the most important phase in your design process. Okay, now, we can move on from that and we can talk about defining the problem. And once we have done that, of course, we will move on to the remaining phases. So, if we focus our attention on the define phase, it is about limiting and defining a clear problem to be solved. Okay. So, we must really define what exactly do we want to solve using our design process. So, as you will recollect, there are the problem and solution domains. Okay. In the problem domain, we are discovering the problem, and then we are defining the problem, and that is giving us this problem definition. So, today that is what we will do. We will use the output of this discover phase, okay, where we have had some insight into the problem, and then use that insight to scope down the focus and come out with this problem definition. Okay. So, this was a diverging phase. Okay. So, we are really exploring a lot of ideas, but now we converge, we come down, okay, and we create this problem definition. So, at the end of the discovery phase, you have done a lot of discovery. Okay. So, you have done a lot of user research, you have done a lot of market research, etc. You have a lot of unstructured research findings from user research, market research, etc. You get these unstructured research findings. What does it mean? Well, these research findings are from varied sources, from many different sources. Okay. User research may be from a survey, market research may be from snippets you have collected from eBay or Amazon, right. So, they are from many different sources, and these research findings are not structured in any particular manner. Okay. They are just random bits of information that you have gathered from many different sources. So, that is where we are at the end of the discovery phase. Now, we move on to the define phase. So, here your goal is to create a clear creative brief that frames the fundamental challenge. So, in this define phase, you are using convergent thinking to narrow down the best ideas and look at what is feasible and realistic. So, you have a lot of research findings here, but now you do not explore many more ideas. You look at those specific ideas and you use that to create your problem definition. So, write this down as a clear and actionable brief. Now, why is it so important that we spend so much time in defining the problem? Well, we must spend a lot of time to define the problem, so that you may be able to confirm this with your client, team or manager to ensure that you are on the right path. Okay. So, this may be one reason that with your client, with your team or your manager, you are working on this challenge problem which you have set out here. when you come out with the problem definition, then you may wish to confirm this with your client. Is this what we should be looking at before we develop our solutions? Okay. Or you may want to discuss this with your team or with your manager. So, that will ensure that you are on the correct path. Okay. If you are not, then you can fail fast. So, if you have not understood the problem itself, you can quickly fail fast, and then you can repeat your discovery phase. Okay. So, then once you have done that, maybe a client thinks that they need an app, whereas your research shows that they need a website. Okay. So, maybe the client who has come in here with the challenge problem, he has come in thinking that you will create an app for them. Okay. But based on the user research and the market research, and then actually nailing those bits down, okay, on analyzing the user research results, analyzing the market research results, you may find that, well, an app will not help them generate enough customers for their product. It is a website with a lot more details, product manuals, etc. That is what they may need. So, you may be able to nail down the right problem by using the definition phase. Okay. So, another example of how this might help. So, maybe a client wants to put a lot of money into pay per click. Okay. So, the client may be thinking that if they get a lot of advertising revenue through clicks, then they will be able to launch their product better, okay, or sell more products. Whereas, your research might show that if they optimize their website, if they take their website and optimize it well, that might be more cost effective. Okay. So, those sorts of insights you can get by trying to create the right problem definition. Okay. So, what makes for a good problem statement? So, the problem statement that you will come up with at the end of the define phase, how can you create a good one? So, firstly you want to make this problem statement human centered. Okay. It should be centered around the human being. So, specific users, their needs and the insights from the discovery phase. Okay. So, you must think about the different types of users that might need that product you are wanting to create at the end of your double diamond design process. Okay. So, who are the specific users? What are their needs? Okay. And what are the insights they are getting from the discovery phase? Okay. So, by taking into account the needs of the users, okay, and the insights you get from the discovery phase, you can create a good problem statement. So, that is how it will become human centered. So, you have to consider the humans for whom you are creating this solution. Okay. It is only by considering the humans you can create a good problem statement. You must think about whether there is enough creative freedom at the end of your define phase. Is my problem statement good enough so that there is enough creative freedom? So, that means at the end of the define phase, you must not be saying exactly what solution technique you will use to solve the original challenge brief. Okay. The solutions technique should still remain vague, but it must be broad enough so that there is creative freedom to create many different concepts which can solve the challenge problem. Okay. So, you must not give very specific technical requirements. Okay. So, you can give some specifications, target specifications, but not technical requirements. So, at this stage you do not know what technology you will use to solve the challenge problem. You just want to define the problem, create a statement. Okay. Also, a problem statement is good if it is narrow enough to make it manageable. Okay. So, if you create a very broad problem statement, so it must be broad enough for creative freedom, but also it must be narrow enough so that you can manage it. You must not come up with 10,000 different concepts which you need to explore. It is just it may be very difficult to explore that many concepts. And then again you must use verbs such as create, define, adapt. So, use verbs to make the problem action oriented. So, the problem statement should have some verbs like create, define, adapt. So, that will make it action oriented. So, you can actually do some action on it and create those concepts, right. So, how do we get to the right problem definition? So, the different techniques we will talk about. So, I have first listed out the techniques. So, you just get a overview of all the different techniques, and then we will talk about each technique. So, the first technique that we will talk about is space, saturate and group. Okay. Then we will talk about affinity diagrams. We will then move on to empathy mapping. We will talk about generating insights from user research. We will use 4 W's and 5 Y's, and we will use a point of view statement together with some how might we questions and why how laddering. Okay. So, these are the techniques that we will use to get to the right problem definition. So, let us learn about these techniques. So, first technique is space, saturate and group. So, there what we do is we use a big wall like this, we collate our observations. So, in the discovery phase we have made lots and lots of observations, okay, and findings. So, we can create a collage out of it. Then saturate it, entire team covers or saturates the display with collective images, notes, observations, data, experiences, interviews, thoughts, insights and stories. So, all of this you did in your discovery phase. You took a lot of, you went to many different websites, you collected a lot of images, maybe you went to the field and collected some images, you took notes from people, you took notes from various magazines, etc. You made many observations yourself, maybe some data that you collected, some experiences that you gathered, you interviewed some people, you had some thoughts yourself, you had some insights into the challenge problem yourself, okay. You had some stories that you came across. So, all of this can be posted on a single wall. Okay. So, that saturates the space, okay, with a lot of information, all of that you have collected in the discovery phase. Okay. So, then once you have done that, you can draw connections between individual elements to connect the dots. So, you need to draw connections between individual elements to connect the dots. That will help you develop new and deeper insights, which help define the problems and develop potential solutions. Okay. So, once you have got all of this information on one place, then you can say, oh, this image can be related to this thought, okay. This note can be related to this experience. So, those kind of cross linkages you can immediately form. Okay. So, that will help you develop new and deeper insights. So, you had some insights here, but now by connecting all of the information that you got from the discovery phase, you can develop new insights, some deeper insights, and that will help you march towards the problems and develop potential solutions. Does that make sense? So, actually in the discovery phase, all of this data collection that you are doing, very often if you are working in a product development group, it might be given to 3 or 4 individuals. Somebody might be doing user research, somebody might be doing market research, somebody might be exploring different websites for images. Okay. So, all of that is coming from different people in the team, they all come together and they put it out in one wall, and then you then narrow it down from there. Okay. So, you go from your analysis to your synthesis. So, you analyze all of these post-its and then you synthesize your problem definition. So, that is one technique of creating the problem definition. Another technique could be using what is known as an affinity diagram. So, this is an example of an affinity diagram. So, here you can see that a large number of ideas can be organized into natural relationships. Okay. So, for instance, percentage purity, percentage trace metals, color, viscosity, parts per million of water, all of these are indicating about your product quality. Overtime costs, overtime total hours, raw material utilization, maintenance costs, material costs, yield, utility costs. So, they are all pointing to what? A cost figure for manufacturing. So, likewise, many of the ideas may group into something such as safety and environment or into maintenance. So, you can organize a large number of ideas into their natural relationships. So, you have hundreds of ideas, but you group them. Okay. So, grouping them creates this affinity diagram. Okay. So, you write each idea on a post-it note and place them randomly on a wall, then examine them as a team and arrange into columns of logical groups. determine a heading for each column, okay, and that is your affinity diagram ready. Okay. So, try to create an affinity diagram for the problem that you are solving on your practical project and see how it goes. Okay. Another technique that you can use is empathy mapping. So, what the users said, what they did, what they thought and what they felt. So, if you create this sort of a quadrant and write out what they said, what they did when you interviewed them, or what they did with the product, whatever you can find out. Okay. Maybe from their visual, from their faces you can find out what their thinking was, okay, what they might have thought or felt. Okay. So, that is having empathy with the user. Okay. You are trying to put yourself in the shoes of that user. Okay. So, that is what is known as empathy mapping. Empathy is putting yourself in the shoes of a user and then mapping them into the 4 quadrants of what they said, what they thought, what they felt and what they did. Okay. 4 quadrants where you place all these user perspectives. Okay. So, that creates an empathy map. The next technique that you can use to nail down your problem definition is generating insights from user research. So, where you clarify your objectives. Okay. So, you take your objectives and clarify them, you collect and organize your findings. Okay. So, you go about, so based on your user research you clarify what is the objective of this design process at all in the first place. Okay. So, clarify that, then collect and organize your findings. So, this can be done for instance using a digital repository. Okay. So, you can use some online repository like GitHub, okay, or any such repository where you can collate all your findings. Okay. Then you can analyze the data. So, from the data that is generated from the user research, we have talked about different methods, qualitative techniques, quantitative techniques or mixed techniques. Okay. So, you can use all of these techniques to analyze the data. Then you can use thematic data analysis to identify the key ideas. So, what are the key ideas that are emerging from all the research you have done in the discovery phase? So, you can do that using thematic data analysis. What are the themes? Okay. How can we group them into themes? So, that we talked about NVivo, right, the qualitative data analysis tool. You can use those sorts of tools to carry out this sort of thematic analysis. So, you can see what themes are emerging on this challenge problem. Then you can turn your findings into insights, which is where you synthesize. Okay. So, you can synthesize the data and come out with a narrowed down definition, and if not, you go back and improve your product. Okay. So, design is always an iterative process and the users are at the center of it. After all, you are doing the design to create something that is of use to somebody. Okay. So, having that empathy, talking to the users, getting their feedback and then incorporating that to change your design. Okay. The job is not done when you have something functional. You want to be seeing whether the users are able to use it the way you intended it. Okay. Are they getting the full satisfaction from your product? Okay. So, let us look at another specific example. So, this is an example of improvement of a jewel case for compact discs. Okay. So, these are some CD cases. So, this is of course, now CDs have gone mostly obsolete, but this example still exists that can help you how to analyze this data coming from the discovery phase. Okay. So, this is a survey that was carried out. So, a group of students in this course were attempting to improve the design and usefulness of the standard storage case for compact discs. Okay, this storage case for the CD, how to improve it, that is what they were looking at. So, already there is a solution that exists and it is out there in the market and people are buying them, okay, but they were looking to further improve it. Okay. So, they created a survey. So, they asked their customers to fill out this survey and return it to the student marketer. And this survey had 14 questions and the users had to rate them from low importance to high importance, 1 through to 5. So, let us look at some of the questions. Some of the questions were like, do the users need a more crack resistant case compared to what already exists? Do they need a more scratch resistant case? Do they need a hinge that does not come apart? Do they need a more colorful case? This is quite bland, is not it? Do they need a lighter case, a streamlined look, a case that fits your hand better, an easier opening CD case, an easier extraction of the CD from the circular fastener? Or should we make it easier to take out leaflets describing the contents of the CD? Should it have a more secure locking case? Should it have a waterproof case? Should we make the case from recyclable plastic, or should we make it so that the cases interlock so that they stack on each other without slipping? Okay. So, the users were asked whether they wanted any of these features, and if they wanted them, how badly they wanted it. Did they really want these features? Okay. Because that will tell us should we invest our time in solving any of these 14. And in addition to these 14 questions, the users were asked to list any other improvement features they would like to see in the CD case. They were also asked, would you be willing to pay more for a CD if the improvements you value with a 5 or 4 rating are available on the market? They were asked, if you answered yes to the previous question, how much more would you be willing to pay? Are you willing to pay 5 rupees more to buy a better case, 10 rupees, 20 rupees, 30 rupees? So, the whole point of making improvements is that you might want to also charge a higher price for the better product, right. So, once you have got the data from the user, so this is a user research, okay. This is in the discovery phase, okay. You are doing a user research, then you can create a bar chart for the responses, okay. You can create a Pareto plot, okay. So, bar chart is showing for each question how many have answered, okay. And then you can organize this in decreasing order, that creates a Pareto plot. So, which questions had the most responses? Question 1 was the most important, a more crack resistant case, and then question 14, which was make it so cases interlock so that they stack on each other without slipping. Okay. So, these were the features. So, by doing this kind of survey, you are able to identify which are the features that need the most focus. Okay. But again, think about it, developing this questionnaire is also not easy. So, you need to put in a lot of thought to create this sort of a questionnaire. So, you see how much thinking goes into the design process, a lot of thinking. Okay. So, design is not easy, okay. And that is why I have been stressing on you all to use the double diamond design process, okay, because it is not straightforward to come up with a solution to a new problem, okay. But there is a process you can follow. If you follow that process, you put in the effort, then you will come out with a product that can beat the competition in the market, that will sell like hotcakes. Okay. Okay, and the next technique we will talk about in creating a problem definition is the 4 Ws. So, asking the question, who is experiencing the problem, that is asked in the problem statement, in the challenge statement. Why does it matter? Okay. Why does it matter that we create a solution? Why does it matter that we create a new product? Why at all? Okay. What is the problem? Okay. What exactly is the problem? And where does the problem present itself? In what context? Okay. Is the problem presenting itself? Then you can also ask the 5 whys. So, an example is, well, why is she not eating healthily? Well, probably because she orders takeaway every day. Okay. So, takeaway food is junk food. So, she is not eating healthily. So, why does she order takeaway every day? Because her fridge and cupboards are empty. Okay. So, she does not have anything in her fridge and the cupboards that she can cook immediately and create a meal. Okay. So, that is why she calls Domino's and gets a pizza. Okay. So, why are the fridge and cupboards empty? Because she has not been grocery shopping in over a week. Okay. She has not gone out to the e-shop and got some rice and dal and some tomatoes and some other vegetables, etc. So, she has not gone grocery shopping. And why hasn't she been grocery shopping? Because she does not have time. So, she is too busy. Okay. Maybe it is time for that final project on desk 641. Okay. So, hasn't been grocery shopping. Okay. Why doesn't she have the time? Because she works long hours and is exhausted. Okay. Everyone sees the cause and effect relationships, and why you need to think about asking these sorts of questions. So, digging deep, really thinking, using your brain to think systematically. Okay. So, once you have done all of that rigmarole, all of those different methods that we have used, or any of those that apply that you can actually realistically do, you end up with what is known as the point of view statement. Okay. So, you can narrow down your problem into a clear statement. So, a point of view is a meaningful and actionable problem statement. Okay. It is a problem statement that is meaningful, it has some meaning, and it is something you can action on. Okay. So, that will allow you to ideate in a goal oriented manner. So, your point of view captures your design vision by defining the right challenge to address in the ideation sessions. So, your point of view statement actually identifies your overall vision for your product. So, it involves reframing the design challenge into an actionable problem statement. Okay. So, the design challenge has come in, let us say, from the customer or the client, a big design challenge, but then you have narrowed it down into a problem statement which is actionable, that is, you can take some action on that. Okay. You can actually work through the develop phase and create some concepts based on this problem statement. So, you articulate this point of view by combining your knowledge about the user, okay, who you are designing for, his or her needs, okay, and the insights which you have come to know in your research or empathize mode. Okay. So, you combine all the knowledge based on your analysis of the user research, okay, understanding the customer needs or requirements which we talked about in the last slide, and the insights which you have come from, which have come in from the research or empathize mode. Okay. So, this actionable problem statement will drive the rest of your design work. So, that is really critical. Okay. So, in all of your practical project work as well, try to come out with this point of view statement. So, how do you write out your POV? Okay. So, there is a POV, you know now that you need to create a POV, but how do you actually write it out? So, you can do that by asking these questions. Who is it that you are solving the problem for? Who is the person? Who are the users? Why are you solving it? Why at all you care to solve it? What are you solving? Okay. What is it that you are solving? Okay. And where are you solving it? Okay. So, who, why, what and where. So, those will create that statement. So, let us look at an example. Okay. So, who is the user? Okay. Why you are solving it? To address their needs, okay, or because you have an insight. Okay. Where? At the time or location, which geography or in what context. So, here is an example. Our young working professional, who we talked about in the 5 whys, struggles to eat healthily during the week because she is working long hours. Our solution should deliver a quick and easy way for her to procure ingredients and prepare healthy meals that she can take to work. Okay. So, we had this case of a user, okay, who is a young working professional, and she had health issues, and the health issues were occurring because she was not eating well, and she was not eating well because she was ordering all this fast food, and she was ordering all this fast food because she did not have anything in the fridge and cupboard, and she did not have anything in the fridge and cupboard because she had not been out grocery shopping, and she had not been out grocery shopping because she had too much work to do, too many deadlines. Okay. So, our young working professional is struggling to eat healthily. So, our solution should deliver a quick and easy way for her to get the ingredients and prepare healthy meals. Okay. How can she get it? Maybe through Big Basket, maybe through Reliance Geomart. Okay. We do not know, there might be some solution, okay, but there is a solution that should deliver a quick and easy way to. So, she does not have to spend a lot of time because she is struggling with time, she has a lot of problem with time. So, that is an example of a point of view statement. Okay. So, here this is the user is our young working professional. Okay. Needs deliver a quick and easy way for her to procure ingredients and prepare healthy meals. Okay. At, that is for work, okay, because she is struggling to eat healthily during the week because she is working long hours. So, all of that is captured. Everyone follows? So, one of the techniques that can help you is how might we. Okay. So, start using your POV by asking a specific. So, how do you write out that part where you are articulating your solution, how your solution should be. Okay. So, how might we, or in what ways might we, how might we deliver the solution. Okay. So, how might we or HMW questions are questions that have the potential to spark ideation sessions such as brainstorms. So, those questions can help ideation for the develop phase. Okay. So, they should be broad enough for a wide range of solutions, but narrow enough that specific solutions can be created for them. Okay. So, these questions must be broad enough for a wide range of solutions, but they should be narrow enough that specific solutions can be created. Okay. So, there must be design freedom, you must have some creativity, but also they must be narrow enough so that you can create very specific products, very specific solutions. So, example of how might we questions. So, how might we make TV more social so that youths feel more engaged? How can we engage? How can we incorporate some social element to TV? Or how might we enable TV programs to be watched anywhere at any time? Or how might we make watching TV at home more exciting? Okay. Or how might we encourage tenants to go paper free? Or how might we educate tenants on how to use the internet. So, answer to these questions will help you create this POV statement. Our solution should make TV more social by incorporating some additional camera and connection to the internet, okay, something of that sort. A camera like features and connection to the internet, but you still do not know what that camera will be, where it will be placed. So, exact design solution you do not know. Okay. So, by answering these how might we questions, you can articulate your POV statement. You might ask how might we enable access to services without the use of screens. Okay. So, these sorts of questions will help create the POV statement. You can also use the why, how laddering. So, asking why questions yields a lot of abstract statements. Okay. So, you can ask a lot of why and how questions, and asking how questions gives you specific statements. Okay. So, asking these why and how questions can help you create the POV statement. Okay. So, these abstract statements are more meaningful, but not as directly actionable. Okay. So, if you ask why questions, why is this happening, then you might get some kind of answer that is very abstract. Okay. But how exactly it is happening, what is the mechanism. Okay. So, that gives you specific statements. So, specific statements are the opposite of abstract statements, they are less meaningful, but very actionable. So, use this why to progress to the top of the why how ladder, where the ultimate aim is to find out how you can solve one or more problems. So, using why and how argumentation, you can reach the top of the ladder, where you can create a statement which will help you drive yourself towards a solution in the develop phase. Okay. So, let us see how we can break down the double diamond. So, in the previous lectures we had discussed the discover phase. Now, in the define phase we have talked about insights, we have talked about themes, talked about opportunity areas and how might we questions. Okay. So, we have really nailed down the insights, we have come out with some themes, we have looked at some opportunity areas and how might we questions. That is giving you this final brief, which is the question, the point of view statement. Okay. The how might we question or the point of view statement, one single statement. So, In the define phase, you have used the findings from market research, the user research, your knowledge of existing products and technologies, okay, and some knowledge of the problem domain to synthesize and bring into focus and create this problem definition. Everyone understands what the define phase is all about? Okay. So, now what we will do is we will move into a specific problem of a suspension fork design. Okay. So, now let us return our attention back to the specific problem, which is to develop a new suspension fork for the mountain bike market. Here the challenge is also to provide higher value for the recreational cyclist. Okay. So, the reason we design a new fork is so that for the recreational cyclist you can provide a better value. Okay. So, let us see what we do. So, this will give you an idea of how to go through different phases. In the discovery phase, you can log how many hours of riding on suspended bikes themselves. Okay. You can log interviews from lead users at mountain bike races. Okay. You can interview recreational cyclists on local trails. You can work with dealers at stores. So, you can actually get you can yourself ride on suspended bikes and see what it feels like, what are the pluses and minuses of the current mountain bikes. Okay. And then you can get interviews done at different places. You can also go to stores and talk to dealers. So, all of that gives you a list of customer needs. Okay. So, doing all of this, and then the key challenge for you is to ask the question, well, how can these relatively subjective customer needs. So, you have interviewed some people, you have ridden the bike yourself, you have gone to some dealers and you have got all disparate data sets. How can you translate these needs into very precise targets for the remaining development effort? Okay. How can the team and the senior management agree on what would constitute success or failure of the resulting product design? Okay. How can you say whether the new suspension fork is actually a success or a failure? Okay. How can you determine that? How can your manager say, yes, after having gone through a design process and created a new suspension fork, it is actually better than the previous one. So, you should be able to tell it very clearly. Okay. So, the next question that you need to address is, how could the team develop confidence that its intended product would garner a substantial share of the suspension fork market? Okay. How can you have confidence that the new fork that you have developed will actually be sold in the market? So, when you put it up for sale, lots of people will buy it. How can you have that confidence? So, how can the team resolve the trade off between the product characteristics like cost and weight? Okay. So, the weight is more, that means you are using more material. If it is the same material, then its cost will be more. Okay. But then if the weight is less, then it may not be very stable or it may have some other issues. Okay. So, those trade offs, how can you resolve them? So, from the customer needs, you need to develop some specifications. So, customer needs are helpful in developing a sense of the issue of interest to customers. So, that customer need may be in the form of very short phrases that are listed out. Okay. So, for instance, the suspension reduces vibration to the hands. Okay. So, reduces vibration to the hands, allows easy traversal of slow and difficult terrain, enables high speed descents on bumpy trails, allows sensitivity adjustment, preserves the steering characteristics of the bike, okay, is lightweight. So, these might be customer needs. So, customers may have told you that they need all of these features from your suspension fork. Just that one suspension fork, not the entire bike, okay. Just the suspension fork, people may have so many different needs, and then you can organize them by importance as well. You can rate them. So, the average rating, you can take that and you can list it out on the right hand side, the importance. Okay. So, that is a list of customer needs. The customer wants that the suspension is safe when the bike crashes. So, if you fall down when you are riding the bike, okay, is not contaminated by water. So, for a single component of an entire product, you may have so many different needs. Okay. So, you need to be able to gather all these needs, and then based on these needs, you then want to develop your solution, right. So, these needs are there, but how do we go from these needs to the concepts? How do we make that journey? Okay. So, these needs provide little guidance on how to design and engineer the product. Okay. So, easy to install, how do you actually convert that into the actual finished product? Okay. How can you make the fork easy to install? How can you make the fork in steel tried? Okay. So, there is little guidance, the needs are there. Okay. So, these needs can be subjectively interpreted, there is no objective interpretation for many of them. Hence, what you need is very specific specifications. Okay. From the needs, we go into what is known as specifications. So, what are these specifications? These specifications spell out in precise measurable detail what the product has to do. So, it will be precise and you can measure it. Okay. So, they do not tell how to address the customer needs, they do not give you the solution, they only tell you that the product must do some things in very measurable detail, okay, conforming to the needs, okay, but they do not tell you how to address the needs. So, they also provide you with an unambiguous statement on what the team will attempt to achieve to satisfy the customer needs. Okay. So, you get an unambiguous statement on what the team will attempt to achieve to satisfy the customer needs. So, for instance, the customer need may be that the suspension is easy to install. So, the specification can be that the average time to assemble fork to frame is less than 75 seconds. So, if the time to assemble is quick, then we can say that the suspension is easy to install. So, this may be the need, but this specification is measurable and very precise. The time to assemble the fork is less than 75 seconds. Okay. So, then we know that the need has been satisfied. So, other terminologies, so specifications are also referred to as product requirements. So, you will find this when you come through a lot of product design literature, instead of specifications, they will say product requirements, okay, or technical specifications. So, what does the specification consist of? So, specification has a metric, okay. So, average time to assemble, that is your metric, and the value is 75 seconds, less than 75 seconds a value. Specification has a metric and a value. So, average time to assemble and your value. So, how do you establish these? So, if we reflect back on our generic product development process, after you have identified your customer needs, you then go for the target specifications, and to establish them, for some products it is very easy to concoct a formulation that satisfies the specifications. For some products it is quite easy, for example, soap or soup. So, it is quite easy to come out with the product which meets the specifications. For technology intensive products, specs are usually established twice. So, you create target specifications and final specifications. Okay. Target is what you would like to have, the dream, okay. And then once you have come out with your selected concept, then you have your final specs. Okay. So, target specs are immediately after customer needs, okay, and final specs are after you have tested the product concepts. So, after you establish the target specs, you generate the product concepts, select the product concepts, test them, then set the final specs and then plan the downstream development. Okay. So, the target specs here, which are not the final specs, are actually your dream, your hopes, your aspirations of the product team. Okay. So, team does not know what constraints the technology will place on what can be achieved. So, at this stage you have identified customer needs, you have got your specs which are metrics and values, but you do not know these concepts may actually place some constraints on what can be achieved. The current technology may not help you achieve that hope and aspiration and that dream. So, that is why you will have a final specs in that. So, team's efforts may fail and may even exceed sometimes. Sometimes you may do better than what you set out to achieve. So, final specs are when you revisit the specs after concept has been selected and you have included technological constraints and production costs. Okay. okay, the constraints coming in from technology and the constraints and the costs assessment. So, how do you establish your target specs? You prepare the list of metrics, okay. You collect your competitive benchmarking information. So, there might be competitors in the market who have a lot of information out there. Then you set ideal and marginally acceptable target values. What does it mean? Ideal is the best case scenario, okay. Marginally acceptable is just about acceptable for what we are trying to achieve, okay. So, maybe ideal is the suspension can take 10 Newton 10 kilonewtons of load, and marginally acceptable it has to be at least 5 kilonewtons, okay. So, and then once you have done that, it reflect on the results in the process. So, once you have got your specs out, then you want to reflect, did we use the correct procedure, did we do well enough, okay. So, preparing the list of metrics is kind of straightforward. You need to contemplate each need in turn. So, you have got a list of needs from the customers, 20 needs, okay, and they are just phrases, English phrases, okay. And then you want to consider what precise measurable characteristic of the product will reflect the degree to which the product satisfies that need, okay. So, what kind of metric will satisfy that particular need? You just need to think about that, okay. So, metrics, examples of some metrics. So, for needs 1 and 3, so if you look back at needs 1 and 3, so needs 1 and 3 were reduces vibration to the hands and enables high speed descents on bumpy trails, right. So, reducing vibration and enabling you to go through very fast descents. So, that translates into a metric such as attenuation from the dropout to the handlebar is 10 hertz, okay. So, 10 per second, okay, in decibels, okay, or reducing vibration and enabling you a high speed descent may be characterized by metrics such as maximum value from the monster from the bicycle in G, okay. The force that is transmitted 5 G, okay, or the minimum descent time on the test track is 5 seconds. So, high speed descent, the suspension fork will be able to do a minimum descent time in 5 seconds, okay. So, that way you can go down a bumpy track and reduce the vibration. So, the vibration may be characterized by some decibels of noise, okay, or in terms of force 5 times 9.81 meter per second square, okay. So, then once you have got all your metrics and you have got all your needs, then you need to see which metric maps to which need, and then you can create this sort of matrix. Metrics are here, needs are here, and you should be able to get at least one metric for each need, okay. So, some needs have multiple metrics, other needs have one metric, okay, and then you can create this metric, then you can see how the metrics are fulfilling all the needs, okay. So, this is also a key element of what is known as the house of quality, which is used in quality function deployment. So, quality function deployment leads to what is known as the house of quality, and that house of quality has one of these elements, okay, but we will not go into that today. So, there are some guidelines for creating these metrics. The metrics should be complete, okay, so that they must address all of the customer needs. They must be dependent and not independent variables, okay. What does that mean? That means they must be variables which depend on the design process, okay. So, the designers can make changes to the design so that the metric can be influenced, okay. So, they must be dependent variables. So, example, mass of a fork is a dependent variable, it depends on the design. So, if you change the length, breadth, height of the fork, then the material will be more, so its mass will be more, okay. So, the mass of the fork is a dependent variable that depends on your design, whereas the material is not dependent on the design. If you change the shape, the material will change? No, you choose the material. Okay. So, that is, so material cannot be a metric, whereas the mass can be a metric which can have a value like 500 grams, 400 grams. Okay. So, this mass is dependent on your design. So, it must be a dependent variable. So, the metric must be a dependent variable. It must be practical. Okay. It must be something that you can actually achieve through your design. Okay. Some of the needs cannot be translated into the quantifiable metrics. Okay. Some needs sometimes cannot be translated into quantifiable metrics, but ideally we want a one to one, well, at least one metric for each need. You can also include some popular criteria for comparison in the marketplace. So, when you are creating these metrics, you can look up, well, other suspension forks in the market, what are the specs that are describing those. You can use those to create your metrics as well. So, here is an example of how benchmarking information is collected. So, these are many different models of suspension forks, and these are the metrics, and these are the values that you can get by looking up the product manual of each one of these suspension forks. And then you can see which suspension fork is addressing which need to which degree. So, if it is doing it a lot, then you can maybe place 4 dots or 2 dots or 1 dot. Okay. So, that will help you get, and the reason we do this is because these numbers may mean nothing. Okay. There are so many numbers, and that is not a visually something you can get some visual inference from. So, to get that inference, what you need is then look at this list and see, okay, for many of the metrics it is actually very good. Here it is a bit weak, here it is a bit strong. Okay. Certain metrics it is. So, that way you can position your product better against this. Maybe if you can get all 5s on all of these, that will be the best product ever. Okay. Does that make sense? Why we create something like this? So, it gives you customer perceptions of how well the needs are satisfied, to the degree to which the customer needs are satisfied. So, how do you set the ideal and marginally acceptable values? Well, you can use basic functions like at least x or at most x or between x and y or exactly x. Okay. So, exactly 3 decibels, okay, or less than equal to 3 decibels, or between 1 and 3 decibels, okay, or is equal to 3 decibels. So, that is how you set your target values. Okay. So, they are a set of discrete values. Okay. So, here you can see for some they have used the greater than sign, for some the less than sign has been used, for some it has been just a specific value is equal to. Okay. The wheel size is equal to 26 inch. And again marginal values and ideal values, see the attenuation has to be at least 10 decibels, but ideally if you can get to 15 decibels then it will be good or more. So, that is how you do that. Then you go to establish the final specs. For that you need technical models and you need cost models. Okay. And then you can refine the specifications, making trade offs when necessary. So, for final specifications you need to then go through your concept development process. So, there you are no longer in the define phase. Okay. Once you have got your target specs, your define phase is finished. Okay. You got a point of view statement and your target specs, that is your problem definition. Then you go through your discover phase, and once you have done that, then you can apply technical models and you can apply cost models. Then you flow down the specifications as appropriate, then reflect on the results in the process. Okay. So, technical models means, for instance, the dynamic model of the suspension performance may be dependent on design variables such as suspended mass, unsprung mass, orifice diameter, the spring constant, the viscosity of the oil that is used in it. Okay. And that then affects the metric, which is attenuation at 10 hertz or the g acceleration when it is going down the bumpy trail. Okay. So, these are your metrics, they are dependent on these design variables which you have some control over as the designer. So, these are design variables which are inputs to these blocks, which is the actual dynamic model or the static model or the fatigue model of the product that you are creating, and based on the design variables which you are tweaking, you can get different values for the metrics. So, once you create that model, which can be in some software like ANSYS, okay, finite element analysis software, you create that model takes in a number of inputs and tells you whether you are able to achieve your target specs or not, and if you are able to achieve, to what degree, what is the final value. Okay. So, that will help you develop the final specs. The other thing you need to do after you have got your target specs is developing the cost model. So, for each component you can figure out how many of those you need, what is the estimate for the highest possible cost from all the sellers, what is the estimate of the lowest possible cost. This is the highest possible cost for multiplied by the quantity 2.5 by 1, 1 by 2. So, that gives you 2. So, total. So, your suspension fork will cost somewhere between the high total of 104.19 and the low total of 78.68, somewhere in between. Okay. So, that is the cost model of the product. Okay. And based on the cost model, if you are aiming to sell that product, let us say at $85, okay. So, you can then tweak your specifications and make them so that it comes for $85. Okay, and that is how you will get your final specs. Okay. So, refine your specs, okay, by looking at the manufacturing costs, okay, and the metric. Okay. So, as you change the metric, as you have a higher G that you can deal with, okay. So, the force that it transmits to the biker, if it gets less and less and less, you want to transmit less force to the biker, the cost goes higher and higher and higher. And you can also plot on this where the other competitors stand. Okay. What is their manufacturing cost and what is the amount of force they are transmitting, and then you can choose where you want to stand, whether you want to be in the marginal values or you want to go really ideal. So, very so really good suspension design. So, really low G value, but the cost is also very high. Okay. So, ideally you want to stay in this range. Okay. Marginal values are here. So, beyond this it is unacceptable, because then you can't deal with all of the competition. Make sense? So, once you flow down the specifications based on the manufacturing and the cost analysis, you get your final list of metrics, and that is the final specs. Okay. So, finally, you want to be reflecting on the results in the process. You want to be finding out, is your product a winner, is your product concept allowing specifications so that the product meets the customer needs and excels competitively. Okay. If not, then the team should return to a concept generation and selection phase or abandon the project. So, if your product concept is not meeting the customer needs or not able to be better than other products, you must go back and generate the concepts again. You have done your target specs, target specs will still remain the same, but you will regenerate your concepts and develop your final specs again. Okay. So, think about how much uncertainty is there in the technical and cost models. Were your technical and cost modeling exercises done in a correct manner? So, to conclude from today's lecture, we found that the design phase is convergent in nature. Okay. You are focused on getting a solution to a problem definition, and your thoughts and ideas are fixed. Okay. It is different from the discovery phase, which was divergent and allowed you to welcome new ideas. In discovery phase, you had a lot of new ideas, it was divergent, but now you have to converge. In the define phase, the design team will analyze the data you obtained. You will filter all your research data, user interviews and personal design assumptions here. Okay. Analyze the data obtained and you can filter all your research data. Okay. And then communicate your project goals. So, these are all the advantages you are getting from the define phase. You can then communicate the project goals ensure the design team is aligned, ensure the client is in line with your problem definition, only then you go into the concept development. Okay. So, to take home, the take home message is you need a point of view statement and a set of target specs that forms the problem definition. So, that is the output of the define phase. So, with that we come to the end of this lecture. Any questions? So, thanks everyone for coming, and I will see you all in the next class.